In this video, we're going to graph quadratic equations. We're going to identify some important points on them. We've already identified the zeros. That's where the parabolas cross the x-axis. We're also going to find some other important points like the y-intercept and what's called the vertex, which is the highest or lowest point, and also identify a special feature of the parabola, which is this thing called the axis of symmetry. In this box is some information about all these different things. The y-intercept, just like with a line, the y-intercept is the point where the graph crosses the y-axis. There's one point of those, and it's always equal to whatever this value of c is. In a quadratic function, just like in the quadratic equation, this value of c is what's called a constant term. It's the term that doesn't have any x's multiplied to it. Every parabola is symmetric, meaning it's a mirror image of itself. And there's a dividing line that cuts every parabola exactly into two equal pieces, pieces that are mirror images of each other. And that line is called the axis of symmetry. Here's a formula that if you'd like to calculate it from just the equation, you can use this formula. For a parabola that opens up and down, that's a function. The axis of symmetry is always a vertical line. Vertical lines have x equals equations. And what is x equal to? It's equal to negative b over 2a, or the opposite of b over 2a. And those a's and b's come from the equation. What's nice is that this dividing line always also goes through this other really important point, one of the defining features of the parabola called the vertex, which is the highest or the lowest point of the parabola. It's sometimes referred to as the maximum or the minimum, depending on which way the parabola opens. Either it opens up, it'll have a lowest point or a minimum, or if it opens down, then it'll have a topmost point or a maximum. The axis of symmetry always goes through this vertex point. So if you could figure out where this vertex is, if you can find this max or min, then you know where the axis of symmetry is going through, and that's just the x-coordinate of whatever the vertex is. So we're going to take a minute here. We're going to do some graphing. We're going to do some graphing on Desmos. You can, if you have a graph calculator yourself, you can always do this on that, or if you want to graph this by hand by plotting points, you're welcome to. And there's plenty of ways to graph these things. If I want to identify some of these important parts, the axis of symmetry and the vertex of these functions, the easiest way is to graph them on a graph calculator or a Desmos, and then we can identify those points from there. So I'm going to take this function and I'm going to graph it on Desmos. So on Desmos, I'm going to do 3x squared plus 12x minus 10. Here's my parabola. It opens up. And it's got some nice features on here. Desmos shows me where the intercepts are. They're not terribly nice numbers. They're like decimals of some sort. But I can find the axis of symmetry because I'm actually going to use the vertex to find that, because the vertex of this is just the lowest point. Desmos automatically graphs that. And the vertex of this function here is -2, -22. So the vertex is the point -2, -22. The axis of symmetry goes directly through that point. It's a vertical line that goes directly through this point. Vertical lines are x equations. So the axis of symmetry is actually the equation x equals whatever the x-coordinate of this vertex is. So since the x-coordinate of this vertex is -2, the axis of symmetry is the line x equals -2. From a vertex of -2, -22. And we can plot that line here. Let's see if Desmos will plot a vertical line. There you go. this vertical line here is the axis of symmetry. And note that we definitely did it correctly, because this, you can think of this green line as like a mirror that one part of the parabola will look into, and it'll see its reflection the same distance away on the other side. Let's try things similar with this function. Let's take this function. Let's find the axis symmetry of this parabola. Let's find the vertex, and then we'll take a look, and then we'll graph that thing. Again, we'll use Desmos to do that. So I'm going to clear these two graphs. And let's plot this one. How about x squared minus 2x minus 3? I'll drag this graph a little bit. So again, this is a parabola that opens up. Some features of this graph. It looks like the y-intercept is at -3. And the vertex is at 1, -4. So I think our vertex is at 1, -4. Which tells me the axis of symmetry is the line x equals the x coordinate of this, which is 1. That's a vertical line that goes right through this vertex.